Hello, algebra students. Mr. Lawrence here, and after today's lesson, you're going to be able to say, I can solve equations by factoring. Now, this is actually really easy. It's just involving factoring and then one extra step. But before we do it, I actually want to talk to you about how do you get 0 in a multiplication problem? Well, wouldn't you have to do like 0 times some number? That would equal 0. Or maybe you could do some number times 0. And that would equal 0. What if there were like 6 numbers involved? You go 6 times 5 times 10 times 4 times 2 times 0. Wouldn't that equal 0? I mean, it would take almost no work to do that problem because that 0 in the multiplication problem changes everything to 0. The most important thing you need to realize here, it's called the zero product property, is that to get 0 for an answer, one of the factors has to be 0. One of the factors has to be 0. Did I say one of the factors has to be 0? Because I'm just making sure you're listening. One of the factors has to be 0. All right, so watch how we do these. They're actually very simple. First, we're going to look at this equation. Notice we didn't have equations before. Today we do. X squared minus 4 equals 0. Well, I'm going to factor this x squared minus 4. I know it's the difference of perfect squares. And so I'm going to take the square root of that, x, take the square root of that, 2, and I'm going to go x plus 2 as a quantity and an x minus 2 as a quantity. Now, I'm going to take the quantities individually. I'm going to take x plus 2, set it equal to 0, and I'm going to solve for x. So I'll get x equals negative 2. Please don't take a shortcut there. Please. Okay? Or, actually, I think it would be an and statement. I'm going to take, not that you can read that now. There we go. And I'm going to take the other quantity, set it equal to 0, and solve for x to get x equals 2. So my two zeros in this case are negative 2 and positive 2, meaning if I put either one of them into x squared, take 4 away, I'll get the answer of 0. All right, here's problem 2. It's a trinomial this time. Lead coefficient is 1. So I'm going to list the factors of 36. 1 and 36. 2 and 18. 3 and 12. 4 and 9. 6 and 6. And I need two factors of 36 that add to get to 12. Well, that'd be 6 plus 6, wouldn't it? So this I'm going to factor as x plus 6 and x plus 6. That equals 0. I'm going to take one of those quantities, x plus 6 equals 0, solve for x. And x will equal negative 6. There we go. Now, I'm not going to do it with the other quantity because they're exactly the same. I'm going to get the same exact answer. This problem actually only has one solution, while the first problem had two. It is possible to have a problem with no solutions, but we'll talk about that more later. All right, problem number 3. Remember, the first type of factoring I should always try is GCF, and I see a common factor of x. I'm going to pull that x out, and then I'm going to have an x squared minus a 16. That'll equal 0. I'll get an x here. Now this is the difference of perfect squares, so it's going to factor like x plus 4 and x minus 4. That equals 0. And so now I have x equals 0. I took this one, set it equal to 0. I'm going to take the next one, x plus 4, set it equal to 0, and solve. X is going to equal negative 4. And then I take the last one, x minus 4, set it equal to 0, and solve. Again, please don't take a shortcut. Some of you are making an assumption in your mind right now, and it's actually not true. This problem actually has 3 solutions, 0, 4, and negative 4. All right, let's try this one here. You know, I see a trinomial, but I also see a perfect square. I'll take the square root, get 4x. Square root there, get 5. 4x times 5 is 20x, and if I double it, I get 40. So this is a perfect square trinomial. So this will factor like 4x and 5, and then a 4x, and a 5. And when there's a plus in the back, it's the Wendy's double stack. Boom, boom. This is similar to problem number 2. I'm going to set 4x minus 5 equal to 0. I'm going to add 5 to each side. I'm going to get 4x equals 5. And then I'm going to divide by 4. And so x is going to equal 5/4, or if you prefer, 1 1/4. Notice I'm not running to a decimal on that. I like the fraction, and you'll see why later. Okay, let's try a couple more examples here. Looks like this one. I've got a trinomial, but the lead coefficient is not 1, so I'm going to multiply those two. And let me see, if I triple 35, I get 105, and if I double that, I get 210. So I need the factors of 210. All right, for what purpose? I'm going to subtract them to get positive x. This is a problem where I'm going to rewrite it as a polynomial with 4 terms. So I get 105. 3 is going to go in, I think, 70 times. 4 is not going to go in. 5 should go in. Let me see, 5 times 20 is 100. 5 times 40 is 200. So I'm thinking 42. 6 should work. 35 times, it'd have to be. That's what I multiply to get to 210. 7's going to work 30 times. 8 is not going to work. 9 shouldn't work. 10 will work. 10 and 21. Okay. 11. I don't believe 11's going to work. 12's not going to work. I don't think 13's going to work either. I'm going to check a calculator on that one. So 210 divided by 13. No, comes out to be a decimal, but 210 divided by 14 will work. That goes 15 times. Uh-oh, what just happened? All right, so 14 and 15. Now I have all the factors. Now I need to take 2 of these factors and subtract to get a positive 1. Well, wouldn't that be 15 minus 14? So a negative 14 and a positive 15. So I'm going to rewrite my trinomial as a polynomial with 4 terms. I'm going to go 6x squared, and I'm going to put a minus 14x plus a 15x minus 35 equal to 0. And now I'm going to factor by grouping. I'm just showing that I'm rewriting positive x as negative 14 plus 15. All right, so I'm going to group. Grab that sign, put a plus in between. Looks like my GCF is going to be a 2x, I believe. So I'm going to factor out the 2x, be left with a 3x, and then minus a 7. And here the GCF looks like it's going to be a 5. So I'm going to pull out that 5 and get a 3x minus a 7. I'm almost done factoring. I got the 3x minus 7 as a quantity and the 2x plus 5 as a quantity. And now I'm ready to do my solving. So I'll take each quantity, set it equal to 0. So I'll take 3x minus 7, set it equal to 0. Add 7 to each side. 3x equals 7. Divide by 3, divide by 3. X is going to equal 7/3. That's one of the zeros. Or you could have set it as 2 1/3. And then I'll do 2x plus 5 equals 0. Subtract 5 from each side. I'll get 2x equals negative 5. Divide by 2. X will equal negative 5 over 2, or negative 2.5. Notice I did not go decimal. So I've got positive 2 1/3 and negative 2.5. My solutions. Okay, one more problem. All right, remember, always look for a GCF, and there is one hiding in here. I'm thinking 2x is my GCF. I think so. So I'm going to divide everything by 2x, but I'm going to pull the 2x out front. So I'm going to get a 12x squared minus a 23x, and then plus a 5. This one's not working out the way I thought it would. This might, no, it's not no solution, but let me try to factor inside now. All right, it's a trinomial. Lead coefficient's not 1. I'm going to multiply 12 times 5 and get 60. And so I'm going to need 2 factors of 60 that add up to get 23. So 2 and 30, I'm keeping a lookout for 23. 3 and 20, oop, there's 23 right there. This is going to factor. Have my 2x. Draw a little line there. Okay, 12x squared. Write it as negative 3x minus 20x plus 5. That equals 0. I rewrote the negative 23 as minus 3 and minus 20. All right, got a 2x out front. And now I'm going to do my grouping. And here I'm going to group like this, group like that, and I'm going to put a plus sign in between. So my GCF here is going to be 3x, I believe. And so I'm going to have a 3x, oops, 3x times the quantity of, excuse me, 4x minus 1. And then here my GCF is going to be 5. The only problem is my signs are both going to be wrong. My x term is going to be negative, and my coefficient or my constant is going to be positive. So I'm actually going to pull out a negative 5. Pull out a negative 5, and I'll be left with a 4x and a minus 1. Okay, I have a 2x, and then we're going to have it times the quantity of 4x minus 1 times the quantity of 3x minus 5. Now this all equals 0. And here I'm going to take 3 parts. I'm going to take this quantity, and this quantity, and set them all equal to 0. So 2x equals 0. When I solve for x, I get x equals 0. There's one solution. 4x minus 1 equals 0. Add 1 to each side. And now I'll get 4x equals 1. Divide by 4. X will equal 1/4. There's the second solution. And then get 3x minus 5 equals 0. Add 5 to each side. 3x equals 5. And divide by 3. So x is going to equal 5/3, or you could say 1 2/3. So this last problem had 3 solutions, 0, 1/4, and 1 2/3. All right, it's really pretty simple stuff. You just have to follow the procedures of what I did in the video. We'll get some practice with this tomorrow in class. Mr. Lawrence signing off. Have a good night, everybody.